Thanks for having me, Sandeep. Yeah, I currently had a security engagement for Prime Video, where I run a program that really works on advanced security controls for various parts of the business. Everything from infrastructure testing and availability around like DDoS bots and scraping, things like data classification and lineage, general like security engineering, AppSec, various kinds of control testing, really about supporting our developers in understanding how to scale security and understanding the controls in place and how they work.
Absolutely, Mike. Thank you so much for sharing that. Hi, everyone. Sandeep here, co-founder and CEO at Deepfence. Mike, thank you so much for making time for this one. Fourth webinar that we're doing in the series of, how top tech tier companies essentially, operationalize security at scale. With that, what we'll do, we'll just move on to the next question. I think this is a little specific question, which is really about a way you are collecting deeper telemetry, deeper context using eBPF, but broadly assuming that, going back to the 4 prisms that we spoke about earlier, which is basically, hey, you need deeper context, either from application/business logic point of view, either you need it from the network, point of view, because you can figure out the reachability of any particular vulnerability or any particular misconfiguration. There's of course the data angle that you sort of spoke about, and the final thing is of course the identity bit. How are you looking at eBPF, specifically as technology which helps you get some of these telemetry in a deeper way? Of course, you can put it on endpoint, grab stuff, but what out of that stuff that you grab is super important. For example, is it network? Hey, I'm grabbing this particular HTTP request that tells me everything about what's happening on the wire, for example, or is the system calls? Is it the file system changes? How broadly do you look at it, right? And of course, this is keeping aside the telemetry, the stuff that you get by calling into cloud APIs, right? Let's assume that that's sort of the lowest common denominator. Everybody has access to the same public cloud APIs. You can call them, enumerate cloud data stores and security groups and a whole bunch of stuff. Sure, but it's not real time. You can do it. You can do a sweep of your cloud every X number of hours or every 24 hours, like a lot of vendors do, and then try to build that somewhat static map of things. But then you need something deeper. You need something which is more real time. I look at this as like X-rays versus MRI scans. Low resolution, quick. That's your cloud APIs. It gets you everything. It gets you a higher level structure of things. But then, hey, you can do it only so often because cloud starts pushing back. There is rate limiting and a whole bunch of stuff happening. How do you see something like eBPF coming in? And what sort of telemetry, valuable telemetry you think that adds? It helps you grab, which helps this larger problem of prioritization, attack paths and everything, that we've been sort of talking about.
Yeah, there's a lot of good stuff to unpack in there. You covered a lot. I think I do think like the TLDR on it is like I think everybody's gonna start seeing eBPF everywhere, and for a bunch of the reasons you kind of alluded to. So like you can take a step back and like cloud security from an overall perspective is the grading of the OSI model, and the metadata is good until you have to ask a more specific question, and then you got to move up a layer. And I think the APIs to eBPF kind of mirror that granularity pretty well. When you look at like I don't know if folks remember the conversation from 3-4 years ago now, when TLS 1.3 was really starting to come out, and perfect forward sequencing, and you can't tap a network and decrypt TLS anymore. eBPF helps solve a bunch of those problems without having to do unnatural network things. The other thing is, like, as you look at like the quote unquote perimeter being dead, right? I miss the days of the old infrastructure where you've got 2 firewalls, a web server and an app server, and you do the your Cisco sandwich, and right, like it's a big vault, right? If you secure the vault, there's only a few ways in and out. And like the world of microservices, data's going everywhere. Your trust boundaries are a lot more logical and a lot less physical. eBPF and being on the hosts is a more natural fit for, I think, like microservices architectures for those kinds of reasons. And then right, being able to look at transactions in real time allows you to build better baselines to drive priorities and context. Like I remember years ago and prior to Amazon, where a utility company had an entire database, I would say exfiltrated out over DNS calls and then wiped. So what happened was, like, you had a bunch of metadata NetFlow that showed you that this occurred, but you didn't have enough telemetry to figure out what happened because it was going to a random DNS server in Eastern Europe. So like eBPF would be a really good control for that, like that kind of scenario. And it would likely have caught it much faster than sort of NetFlow sampling, because it because of the scale at the time. And now, granted, this was years ago when compute's gotten better and algorithm detection has gotten better and big data processing's gotten better. But we talk about drift, we talk about context. Having data on the wire helps answer those questions, and eBPF can give you a real-time answer, i.e., what data is going to third parties. That's going to be a lot easier to do with things like eBPF than trying to sniff API gateways, for example.
Yeah, oh, absolutely. And, there is always the context that you get at north-south boundaries, and the east-west is absolutely good. You have eBPF probes running along with your microservices, which are getting you everything that you need. You touched upon so many cool things here, Mike, that I am passionate about. Really, everything old is new again. It's just that it has to be deployed and implemented differently for cloud, really, right? You need to handle the north-south boundaries as well as the east-west boundaries, service meshes, you name it, really. And eBPF is a perfect candidate. The bit that you spoke about in terms of perfect forward secrecy, you know what, that's one of the things that we do, Mike. I don't want to put that plug here, but that is such a huge blind spot. I think about, and I could be wrong about this number, but correct me if I'm wrong here, about what? 65% of the traffic within cloud is completely encrypted, right? That's a huge blind spot for you, really. And the only way to really sort of do something about earlier was put a MITM proxies. That sucks. Nobody wants yet another proxy, really, in your microservices environment, really, right? So eBPF really opens doors to be able to look at what comes in, what goes out, and what changes. In the DNS bit that you mentioned about, what, I have a question that I know it's not probably there on this particular slide deck, but that we're touching upon really is, so a cloud security solution or runtime security solution should also look at not only file system and system call changes, but also look at ingress traffic and egress traffic at a process level. And we're talking about HTTP, HTTPS, we're talking about DNS, we're talking about everything that happens on top of TCP as well, really. That would give you that comprehensive security. Am I right in saying that, Mike?
Yeah, and I think the other advantage you tend to get is just the distributed nature. When you think of what it takes to have a giant log ingestion thing that just snarfs everything, SIMs will be around forever and SOAR platforms will be around forever. But this idea of, hey, we're going to go ingest all our web logs everywhere in real time and process them doesn't, it actually slows down things like detection. And if you're trying to measure, how long does it take to detect something? How long does it take to mitigate it? eBPF lives in a good place to solve those kinds of problems, right? So you take a little compute from everywhere versus a big central compute that's just constantly churning. So I think that's one example. I also think there's, the distributed nature when I talked about, hey, mapping to things like the, like the NIST framework. You can protect and respond with eBPF as well on those hosts directly, right? Like I don't want to call it like the next generation of endpoint security, but there's certainly, being able to get certain kinds of controls on the host helps than figuring out how to mitigate it, right? Like if you have something to your proxy example, if you had stuff not going through the proxy and you needed to implement a control, like where do you implement it if it doesn't go through the proxy? Especially if IP is not a specific enough, flag, like you just don't want to be blocking IPs. That tends to be a futile effort, especially at scale. And you tend to break as much as you fix. So I think it also gives you, I guess the point I'm trying to make is it gives you a much more specific place to implement and scale a control.
Absolutely, Mike. And I think this also sort of solves the prioritization problem because you're looking so much deeper now in traffic. You're looking so much deeper into, and traffic is basically a manifestation of, behavior really within your cloud environments really, right? So it helps with prioritization. It helps with deeper visibility. That essentially enables deeper detection and protection at runtime as well. So absolutely, yeah. eBPF sort of gives you that control that, we just didn't have back in the day, right?
Listen to the full webinar at deepfence.io/resources.